I'm not an expert in roses. However, when people, their roses die, they send me soil samples. I used to be the lab director at A&M. I was at Oklahoma State prior to that, Kansas State prior to that, so I've analyzed over 1 million samples of soil, water, and foliage. And I always get the samples where there's a disaster. So that's kind of sad. Nobody samples when it's really doing good, and thank you for making the right recommendation. So I've run into a few wrecks. So even though I'm not a rose expert, I've been around a lot of different plants, and my background is soil chemistry and plant physiology. And so some of the talks I'm asked to give are why do labs different recommendations, and then recently root diseases affect nutrient uptake, and then the last few years I've been asked to talk about world fertilizer supply. And so I've taken my 3 talks that I'm usually asked to give and given a little shortened version. And you'll run through here. Now if anyone has any questions during the middle, if something pops up, don't worry about it. Just raise your hand and we'll discuss it. If I make anybody mad, just go ahead and wave your hand too. All right. All right, when I got to A&M, my boss, Dr. Runge, he said, Larry, we've got about 5 or 6 labs in the state. Your job is to make sure every lab in the state's running the same method, making the same recommendations. I'm tired of all these phone calls of why all these labs disagree on recommendations. So, computer modeling, mathematics out the wazoo. We're going to sit and take a soil sample. We're going to put all the inputs we can into a computer, and we're going to make a recommendation. Well, we ended up with 300 crop codes and zip codes and, if then, if then, if then. And then I got to thinking, my uncle was a famous lawyer involved in malpractice. He had a medical degree and a doctorate degree. And so these insurance companies spent millions and millions of dollars on computer programs that would look at doctors' diagnosis based on blood analysis or whatever to keep a boo-boo from happening. So how many of those programs are being used today in 2015? Zero. Computers cannot think. It's ones and zeros. So when you have a biological system, we're not there with our computer models yet. So my first 12 slides, we're going to cover advanced soil chemistry and plant physiology in about 3 courses in 12 slides. Sometimes it clicks, sometimes I see just blanks and it goes right over their head. So here we go. I'm trying to explain why labs could differ. And it's okay. What you want is that you want that one doctor to make the right diagnosis. You're hoping that one guy. And so with soil testing, you want one lab to be right and you have trust in it. All right, basics of soil fertility and plant nutrition. So back in 1450, we had no idea what it would take for a plant to grow. So Van Helmont, being a famous Dutchman, he weighed a pot in the soil and planted a willow tree in a pot. There we go. And all he did was add water for 2 years. And that plant grew. So all he had added was water. He weighed the soil, and at the end of the 2 years, the soil weighed 2 ounces less than when he started. So what do you conclude? You got this big plant. All you added was water. Soil didn't do anything. That's probably experimental error. So water is the only thing you need. Well, that threw us off for about 400 years. So, a German, von Liebig, he discovered that most of the weight of the hydrogen and oxygen in the plant came from the water, but most of the weight of the plant was from carbon dioxide. Photosynthesis, taking in carbon from the air, making sugars. Most of the weight of the plant was from CO2. So the 2 ounces unaccounted for are nutrients from the soil. So that's a very small amount, but if you're missing one of them, you do not have any plant growth. So, these are the essential nutrients. And so in our soil chemistry and plant physiology classes, we'd spend an hour on each one, how it came from the soil, how it was used in the plant. We learned that at C. Hopkins Cafe. It's managed by my close cousin Mo. People argue about these, but it turns out that aluminum and silica recently is very essential for plant growth. Silica is very essential in those cell walls. All right, so luckily, okay, in hydroponics, in a hydroponic solution, you have to have each one of those nutrients. In the soil, in the field, there's only been 9 show that limit growth. Nitrogen, phosphorus, and potassium are the big 3. Like on a fertilizer bag, it'll be 13, 13, 13. 13% nitrogen, 13% phosphorus, 13% potassium. American Plant Food, we've been in business since 1964, and we're the ammonium sulfate people, so we're the sulfur people. Sulfur does the same thing as nitrogen. It builds proteins, it's just needed in less quantities. Zinc and iron are micronutrients. Magnesium, boron, and recently chloride has been shown to be very important in plant growth. So for 50, 60 years, farmers and ranchers and growers would say, I put out potash where the soil was high in potassium and the plant looks better. And all the professors in the world said, nope, it's not potassium, you're wrong, you're wrong, you're wrong. And finally a professor, Paul Fixon at South Dakota State, he just got to thinking, for every pound of potash you put on a pound of chloride. Potash fertilizer is potassium chloride. It's mined in Carlsbad, New Mexico. So he was up at South Dakota State, which is a little bitty school, and he didn't get to go to A&M or Oklahoma State or Colorado State. Little South Dakota State. He goes out, puts out potassium chloride, calcium chloride, magnesium sulfate, gypsum. He put out everything. He even put out salt. Sodium chloride at 20 pounds per acre. Every plot where he put out the chloride, he had a 20 bushel increase in yield. You can imagine all these famous professors making fun of it, but Paul had his data right. And it took about everybody laughed at him. He was a good scientist. But even when you got your data, it still takes a while to get over 60 years worth of people saying chloride's bad. And it turned out that chloride is important for turgor pressure in a cell. The only way water transpires through a plant is you have more salt in the leaf than you do in the soil. That's why if you have a salty soil, as soon as it gets 90 degrees, those plants wilt. That water has to evaporate off that leaf. It's like an air conditioner. Well, that water is trying to dilute that salt in the cell at the top. And it turns out potassium and chloride are both needed for that. Anyway, I'll get off my chloride deal. Paul, he took it in the shorts for a while. All right. So we have those 9 nutrients. So we're going to cover the chemistry of 2 of them and how we make recommendations. So it turns out that von Liebig, who figured out all the nutrients needed, got in a big argument with Metrolich, and they're both Germans. Von Liebig said for each nutrient, when you get a response, if you add 20 pounds, you double your yield, you add 40, you double it again. So he said we use a linear equation making recommendations. Metrolich said, oh no, you're wrong. When we have a nutrient deficiency, when we add a little bit, we get a big jump and then less and less and less. So believe it or not, that was a big factor. Turns out von Liebig theory is correct for nitrate, sulfate, and chloride. And see, these are mobile in the soil. They do not attach to the clay. So the way these are taken up is when the water transpires through the leaf, you can actually have competition between 2 plants right here for nitrate, sulfate, and chloride. And so in soil testing, this is easy to do. You can take that soil, shake it with water, filter it, measure how much nitrogen or these others in the soil, you know how much is in the crop, and you add the difference. So it's an addition, subtraction. So that's as easy as it gets. All right, for Metrolich, it turned out for immobile nutrients, phosphate, potassium, and calcium, like limestone, if you put that on the soil surface, that's where it stays. You've got to incorporate it. So the root actually has to come in contact with these immobile nutrients. So that's a big concept. If everybody falls asleep after that, that's all you need to know. So when we have our established beds, and we put out triple 13, our P and K is sitting up here. It doesn't mean it's not all unavailable, it's just when it's wet, there'll be a few roots pick it up. So it's very important to get that incorporated prior to planting. It's also one of my recommendations, because of this problem, is I like the spike method, to take a crowbar or make holes and pour a little fertilizer around the plant. That's another take-home lesson. Now nitrogen, generally from the commercial fertilizers, it converts from ammonium NH4 to NO3 within a few days, and it'll move with the water. Now your organic nitrogen fertilizers from proteins, you know, alfalfa, fish, whatever, see, that's tied up in the proteins. That's not, if it moves down, it's very, very slow. So on those nitrogen sources, again, we need to incorporate it, either spikes or scratch it in a little bit. Okay, so this in soil testing labs, you can add water, all the labs agree, but over here, we had to come up with the chemical extractant method. So in that soil, let's just look at phosphorus. 99.9% of that phosphorus is in a solid phase form. It's a rock. So in the soil solution, there's 0.1%. So this is an equilibrium, this is chemistry, it's an equilibrium deal. As the plant takes this up, and you have wet and dry, wet and dry. I didn't say all dry or all wet. When it's all dry and all wet, this doesn't happen. But if you have a rain, wet, dry, then that soil dissolves and it replenishes that. Okay. So labs develop different extractants, not just water, some acid extractants to get a measure of this top arrow. High pH soils, which we have some around here, those blackland, high calcium, high pH soils, they tie up phosphorus fertilizers. So this bottom number, or bottom arrow, whenever we put out phosphorus, we put it out in the fall thinking it'll be ready for the spring. 90% of that's taken up. So we need to put it on when the plant's actively growing or just before. Okay. Acid soils, it's not that way. It's just on the high pH and the heavier soils. So we have to go out and calibrate the soil test, and so Dr. Malik, Adolph Malik at North Carolina State, long story on this, he developed the Malik 1, he developed the Malik 2, which was a kind of a disaster, and so he ended up modifying Dr. Bray's method, and even though it's Dr. Bray's method, they called it the Malik 3, so that's the one that's used the most. And it's a hodgepodge of different chemicals and chelates. So you go out in the field and you have a place, let's just say this is 10 part per million phosphorus, and you don't put out any phosphorus, and you have a check plot and you put on 40 pounds. And let's say the soil test is 20 part per million and you double yield. So you do this test, and there's another one from Kansas when I was in grad school. Yeah, a little phosphorus early on, it affects the root zone, affects the grain fill on all plants, blooms, flowers, pecans. Phosphorus is critical for that. Okay, so that little X from our study, we had a 20 part per million, and without phosphorus fertilizer, we had this yield, and with 40 pounds of P, we had that yield, so we're at 50% of maximum yield. So you go out and do several studies, and you have a nice little curve like here. We don't want to talk about where we have problems. The acid Beaumont clay, it can test low and you never get a response because they've got a lot of iron phosphates, and when those soils are wet, they release phosphate, so the soil test doesn't work. When you run a bunch of soil samples, you find where it doesn't work. In the Blacklands, like in Waco, out in that area, we had some soils that tested very high, but we would get tremendous phosphorus responses. It turned out those soils, when they're wet, do not release that calcium phosphate. But in general, the soils that are 6.5 to maybe 7.2, that test works pretty well. Now here's the difference between a university and a public or a private lab. The critical level, you'll notice, is 85% of maximum yield. And so a university lab would say this is low, medium, and high. If you're at this level, you don't recommend any more phosphorus. But the private labs keep recommending fertilizer. It turns out what I believe is when we put out studies in the field, there's variability, and everybody's looking at that now. And a lot of the studies at universities were just in 4 replications. So if you have a plot here and a plot there and it varies 15%, even before you put out your treatment, you've got 15% noise. You can't prove statistically that you get a response. Okay. So I believe that the private labs are probably right, that we should go low, medium, and high, because I've seen a jillion studies where you put something out, you'd have a 10% increase in yield, but statistically you couldn't prove it. So I'm in this camp here, and especially for what I found turf farms, and well, there's a lot of people, when I got away from the university was very conservative, and I got out into people making money, and the turf farms were the best. And I would recommend something, and Willie Gravonovich, he's a corker, he'd say, Larry, I'm going to double it. And I said, no, you're wasting your money, and then he had me out. He was the first one with green grass in the spring, and when it froze in the fall, got to 25, 26 degrees, he still had green grass. So even though he did, with this university type thinking, he had grass to sell the soonest and the latest, and it was because he was up in this range. And then I looked at other crops, and it's the same thing. Okay. Here's the problem. You've got all these different soil types, so you have to calibrate that soil test on all the crops, on all those soils. That's more difficult than medical. I mean, one of my old professors would say it's not rocket science, it's harder than rocket science. And I'm believing it. Mother Nature is very complicated. It gives us a reason to use our brain. All right, I'm going to gripe a little bit. The Malic 3, a lot of labs are starting to use that for all the extractants. It's cheap and dirty. Wish that camera wouldn't on. You can do this test for $10 and make money, because you have one extractant, you shake it, you put it in the machine, and you get the numbers. And if you make a nice, colorful graph, that sells. I've had some very talented, wealthy people look at this and say, this is the greatest thing in the world. But you cannot, I have problems with the Malic 3 being used. It was originally used for phosphorus, but now it's used on these elements. On acid soils, it might work. On high pH soils, I don't think so. But they use it on the micronutrients. I totally disagree. There are a lot of labs doing that. I'm going to put a real plug in. This is a lab I'm using, and I know the folks, worked with them for years. Servitech, they've got a lab in Amarillo and Dodge City in Nebraska, but they're using the old-time methods, and they're top quality. It's a good lab. It's the one I use. I know them all. That's all I'll say. And they do potting media tests also. If you've got an organic soil that's mainly potting media, peat and stuff, they can do a potting media test, and it's just a water extraction. They do a good job with that too. All right. My tidbits on soil. Yes?
Is there a website for Servitech?
ServitechLabsWorld.com. And Roxanne in Amarillo, she'll take care of it. All right. Soil pH. What is soil pH? Moisture, how does that affect nutrient availability? Acid-forming fertilizers, chelated micronutrient, hang on, don't leave me at it yet. Root exudates, phytosiderophores, Nutrisphere and Avail, nutrient enhancement uptake. This is about 20 years worth of me trying to figure out why my soil test didn't work and why certain crops did better than others. All right. Okay, on low pH, regardless of the soil test, as the low pH goes down, iron and manganese availability goes up. So if I see, yes sir?
Can you define low and high pH?
6 and below, 7.5 and above.
Okay.
If I have a low test iron or low test manganese and the pH is 6.5, no way you're going to get a response. If you're at 7.5, you could. In other words, our soil tests are, again, that computer, it's based on numbers. It can't look at what that pH is, which affects the curve. Okay. High pH, iron and manganese go down. Okay. Now, when it's wet, manganese shoots through the roof. When it's dry, manganese goes down. So really, manganese is the worst soil test we have. When we get a soil sample into the lab, the first thing we do is dry it. So I have all these samples coming in, or people sending in samples to the lab I just showed, and they send it in to American Plant Food, and it says low in manganese, and people are recommending manganese. It's just a waste of money because the lab's dried the sample. As soon as it rains, that manganese goes up. That's the biggest bugaboo. All right. All right, what is soil pH? That's what I got my master's and Ph.D. in. pH, that's a little p, the negative log of the hydrogen ion concentration.
That's pH, the pH of dirt, Ph.D.
Or water, really should be of water.
Okay.
pH was originally intended to be used on aqueous solutions. So soil is a solid. So what the heck is a soil pH? We don't know. But it's possibly the best indicator of soil fertility. The older soils, we've had acid rain for millions of years. There's carbon dioxide, it's carbonic acid falling, it's pH 5.2. If you put water out in the air long enough, it's going to be pH 5.2. And so that's raining. And so the older soils, and when I say older, they've been there for longer time periods, like Alabama, Georgia, all the way over to almost Caldwell. We've got some soils in Texas that are almost cousins to soils in Georgia. And that's why coastal and Bahia grass grows so well there. But anyway, the younger soils, as you go west, as you drive toward the panhandle, you notice there's a white layer on the cutout areas, on the cliffs. That white layer is calcium carbonate or calcium sulfate. That's how far the rain, the acid rain, has leached the calcium and magnesium down. So the further west you go, that white layer gets closer to the surface. And you get into East Texas, it's gone. It's gone. All right, to explain pH. pH is such a large number, the chemist made it a negative log of the hydrogen ion concentration. And when I'm in a building with 1 foot tiles, it's pretty easy. Let's say pH 7 is right here at this 1 foot. pH 6 is 10 tiles over. pH 5 is 100 tiles over. pH 4, it's across the street. It's 1,000. Same way going the other way. So when I have my guys go at 5.2, 5.3, my crop's fine, everything's fine. At 5.1, 5.0, even 4.9, well, it's not that different than 5.2. Yeah, you just went across the street. Just to get it. All right. So when you add a lot of fertilizer over years, fertilizer is acidifying. There's hydrogen with that nitrogen. When the NH4, even from that organic fertilizer or whatever, if it gets converted to nitrate, NO3, then that hydrogen's left in the soil. One of the Ph.D. prelim questions I had is why in the world did plants evolve to take up nitrate instead of NH4? Because it takes a lot of energy to convert. It goes right back into protein and NH4, so why did Mother Nature put it through that cycle? No one knows. No one knows. That's a tough one. But anyway, you get the acidity, and once you add so much hydrogen to a soil, it dissolves the clay, and you get soluble aluminum, which is a heavy metal, and heavy metals stop root growth, stop cell division. When these cells are on that root tip, I don't know what's going on with the plant in the root tip, but if you put in a sand, if you put a pebble of fertilizer over to the side in the dark, and you plant a plant, it heads right to that fertilizer pebble. Plants can't think. How does it know to go? It does it every time. You put one over here, over there, it doesn't. But when you have acid soils with aluminum or zinc or lead or something toxic, those cell tips, they cannot communicate. It's just like our cells when they go to cancer, they can't communicate with each other. So something happens with that electron transfer. But at low pH, you don't have a root system. So if you don't have a root system, you got to add twice as much water, twice as much fertilizer, and you have to add lime to neutralize the acidity, calcium carbonate. All right, so this, I'll get going a little faster, but there's always arguments of how much sulfur is really needed, and sulfur is acidifying. And if you add just a little bit, you don't get a big drop in pH, but if you just overload it, it really drops. Okay. Fertilizers, urea, ammonium nitrate, and ammonium sulfate. If you put them in the soil, the enzymes, urease enzymes, and nitrifying bacteria in optimum conditions, all the ammonia in that urea in 7 days will all convert to nitrate. So you get to nitrate and then you get heavy rain, it moves with the water. Remember that nitrate moves with water. So these are quick acting fertilizers. These fertilizers work best when you have a little 1/4-inch rain and you're in a drought. If you get a flood, these things never work. Our ammonium sulfate it's not legally a slow release, but it takes 21 days to convert to nitrate. So it's kind of a slow release fertilizer. Okay. In Texas, we really don't have a fertilizer law that defines what a chelate is. A true chelated micronutrient in a fertilizer is very expensive. And so a true chelate, this is EDTA, and you see these little carboxylic groups, they want to grab these four, they want to grab onto an iron. They've got a negative charge, an iron's got a +3. That chelate reacts with that iron and it holds it. They're dancing partners. So that keeps it away from that soil from being tied up. But that's a true chelate. I've got there's a camera again. Some people in Texas that add citric acid or even some poultry litter water, and there are organic acids, humic acids in that. Then they add zinc sulfate or iron sulfate and they call it a chelate. Yeah, it's kind of a chelate, but not the true chelate. All right. Over the past few years, there's been a controversy. There's these snake oils, and one of them is Nutrisphere. There's a Veil. There's a list of them. And when I was at Kansas State, we put out some studies with one of these, and it's hit or miss. But one of these studies out in Hays, Kansas, I mean, you'd never expect it. We drove up there, and here are these plots. 4 treatments, 5 replications. And they said, Larry, which one's the best one? And I went 101, 203, on and on and on. And they looked, and I mean, they about had a heart attack. It was the one with Nutrisphere. We went to another location. See, it was supposed to be a snake oil. We didn't want to see a response. But we had other sites in other states. It's a hit or miss. But if you have 4 replications out there, and sometimes it happens here, 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 and here, something's going on. There's some science behind it. It's just, there's no way you can do that by luck. Okay. It turns out, I have a theory. Remember that chelate that grabbed that iron? Well, it turns out that a lot of the plants have a similar compound that they leak from those root tips. And I think that's an adaptation. So if there's a deficiency, some species can exude a chelate, and they call that a phytosiderophile. And I think it grabs that phosphate from calcium phosphate, or that iron that's tied up, or that zinc. I think Mother Nature gave it a method to go get it, but it's variety specific. And so that Nutrisphere is very similar to those natural compounds that are root tips. And it turns out for nutrients to be taken up, it's got to go through that Casparian strip. This is heavy plant physiology. But basically you have, let's just say you have a whole bunch of line of fingers in there, in that Casparian strip. And there's certain doors that, there's a door for zinc, there's a door for phosphate, door for nitrogen. I think there's another door for a chelated nutrient. So when we get responses to this Nutrisphere, it's on high yielding conditions. In other words, I think that's opening 2 doors. So, guys, all these organic products that we really don't know the chemistry of them and what they're doing, what happens with those compounds, what happens to those products in the soil as they break down? The humic acid. Humic acid is a buzzword, but there are long chain carbons with carboxylic acids out there. And if you do studies with high fertilizer rates, you'll get a certain amount of yield. And this has been done. And then you do manure or some other organic product. You get a yield plateau. And Dr. Stewart out in Bushland, I think it was at Bushland, he decided I'll take high manure and high fertilizer together. Boop. It bumped up. And if you look in the literature back to the 50s, anytime they used an organic carbon source with natural fertilizer, both of them are synergistic. And I think we're opening two doors on a lot of those plants. So, based on what I told you, why labs won't agree, soil testing and plant analysis is 50% science, 50% experience. I got in trouble at the university because I said it's highly empirical. It's a rule of thumb. It's 50% science and 50% experience. And the scientists, physicists, and they can measure an apple dropping from a tree, but when we're growing plants, it's a different deal. All right, root diseases. I'm going to go through this because I did everything I wanted to do, and nothing's growing. Okay, this is a Bermuda grass root, healthy growing, and this could be any other plant. All right, no root hairs. Note the root hairs, absent dark color, cortex, and stem. If you have a fungal infection, in other words, when there's stress on the plant, it leaks those carbons and sugars, and so a fungus attacks it, the roots and leaves. And so then you have a dark color. What we had with Bermuda grass decline, I had all these growers adding a lot of fertilizer and a lot of lime, and the more fertilizer they added, the deader that Bermuda grass got. So, man, we had all this complex Bermuda grass, blah, 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 blah. It turned out it was the guys pushing production, taking a late hay cutting, and so that grass didn't get a chance to winterize. And all plants, I got to studying this, when we go into cool, wet, dormant weather, that plant's got the most important time for the health of that plant is going into that. If that goes in with the roots being with stress, that's when the fungus gets there. And if the fungus gets there, then you throw fertilizer on it and the fungus goes again. So I think that happens with all plants. So I had people throwing out tons of fertilizer in the spring, and they really ought to do it August, September. Right when we have a few rains, the temperatures get cooler. And then later on in the spring, you can add a little. But the worst thing in the world is nothing in the fall, and then here comes the spring, and you throw a bunch out. Okay. So what we found out is if we added a little bit of ammonium sulfate, it turns out these diseases really love nitrate. You want to stay with the nitrate. We don't have to worry about it in Houston because of the Texas City problem. In fact, that's the whole reason American Plant Food exists. Ammonium sulfate will not blow up. It's used to put out forest fires. So that's why American Plant Food got started. But anyway, the ammonium ion, for some reason, the fungus doesn't like it. And so if we fertilize it in the fall with a little ammonium sulfate or DAP, ammonium phosphate, that it resists that fungus and the plants come out of it tremendously. Okay, root disease, plant stress, there we go. Yeah, the only thing that's worked is an ammonium type compound in the fall. Okay, hang with me guys. This is my big talk that I've been giving, and it may not be down for you, but it's my life. We've shut down about 50% of our fertilizer manufacturing in this country over the last 15 years.
50%.
Yep. Well, I'll talk about AgriPhos. The phosphate people across the ship channel from us, they produce 750,000 tons of phosphate a year, and because of the hurricane, the rock phosphate has gypsum in it. They add sulfuric acid to the rock phosphate, and that rock phosphate has some heavy metals and a little radioactivity. So the leftovers from that is gypsum, calcium sulfate, but it's radioactive. So there's huge mountains of semi-radioactive. It's just a little, But it's right by the ship channel, and when we had the hurricane, it ended up in the ship channel, and so they had to shut down. So I'm trying to help them. I'm consulting with our neighbors. We're trying to get grass to grow there. And it's with the slopes, the older ones, I'm sorry, I'm getting through. We've had to flatten the mountains because we've got to have water infiltrate from the rain to keep the salts from coming up. The older ones that are like this, we can't keep the grass to grow. If we can't keep the grass to grow, because then that's keeping everything from going into the ship channel. If we can't keep the grass to grow, then mobile's going to have to move those mountains. And that mobile is tied to it. It's huge. But anyway, we lost 750,000 pounds plus the environmental problem. Anyway, China and India are just going through the roof. A friend of mine went to China, and he said the building going on there, the planting of crops, it's just, it makes downtown Houston, you just multiply it by 100 how much building. In the middle class, they think they have 200 million people making over $30,000, $40,000 a year, so they're getting appetite for cars and food. I'm getting soil samples from China to grow pecans, almonds, watermelons, alfalfa for their dairy, but they're getting a taste. Huge demand. Okay, this is Mr. Winburn. He's the founder of our company. When I first started working for American Plant Food, I went to a meeting, and my friendly county agents, this was along the coast, we were at a 5-county meeting, and they were laughing that the fertilizer companies were selling fertilizer at less than cost. And they were saying, this is the greatest thing in the world. And I mean, all the fertilizer that I'm getting ready to talk about, it was $80 to $100 per ton. And so it was fun to give talks about fertilizer then, because it just doubled your money and you're making money. And I went and told Mr. Winburn what they said. And he was 84 at the time, reading the Wall Street Journal in the board. Dropped the paper down. He said, Larry, it's a bad thing. He said, competition is good. He said, what's going to happen? There's only going to be a couple of them in charge of each nitrogen, phosphorus, and potassium. If I was a younger guy, I'd buy the assets of Mississippi Chemical. But he said, I'm too old, I'm not going to do it. And I told people what he said. Everybody laughed at him. Okay. Here are the number of, in the 70s, the number of nitrogen producers. And now we're down to 19. This is phosphate. We had 33, we're down to 7. Potash, look at that, 16 down to 5. He hit it on the nose, but even worse. North American nitrogen capacity, CF, Agrium, and Terra, and Coke used to be the top 4, but Terra bought Mississippi Chemical assets. CF Industries bought Terra for $4.7 billion. So now it's CF, Terra, and Agrium. So you've got the top 2 in the North America in charge of 69% of the nitrogen. Mr. Winburn was right on the button. Now here, you know, Cokes are strong, but they're little players. But they're coming. They're coming. All right. So you've got 2 people in charge of 69%, which it affects all food, everything. Okay. Here, phosphate's even worse. Mosaic, which is really Cargill, it was interesting that when the crash happened, these private, well-run companies like Cargill and the Coke started buying up assets that nobody wanted. And everybody goes, what's going on? Well, the Mosaic / Cargill people, that rock phosphate in Florida, and potash, I'm going to get to the potash too. If you see China and India increasing food demand, and you've got a certain amount of raw materials that make fertilizer, you can shut some plants down because that rock phosphate and that potash is going to increase in value just sitting there. So you lower production, double your price, and say take it or leave. Oh, in Brazil. Okay. Miss Foss, the last part of Mississippi chemical, They filed for bankruptcy. They got in trouble with the EPA. And so now you've got 74% one company. If we want to go get phosphate, we used to go across the ship channel. Now we got to go to, well, we make a deal with the guys in Florida maybe, but we go to Morocco or Tunisia. So what we've had to do to get our phosphate is we had to get a warehouse down in Galveston, and other people have built. We get a DAP barge, and what's the problem is we could go and get a truckload or a rail car when we needed it. Now we've got to decide how much phosphate we got to buy it in the fall, sell it in the spring, and are we going to have a drought? Are they going to plant corn? You got to make a big decision. And so last year, 2 years ago, we bought 20,000 tons of DAP, brought it from Florida for $7.5 million. And so then we put it in a warehouse, which costs a lot of money. You got to unload it, then you got to load it out. So there's a lot of expense, and that's how phosphate ended up $560 a ton, where it used to be $125 or even $300. Now we're way over $500. And here's our potash guys, PCS and again Mosaic. There's 5 mines, 6 mines, Agrium. The top 2 are in charge of 85%. And this is their inventories. I don't know if there's any Monty Python, probably too old. Anyway, wink, wink. Anyway, they just shut down production. And they said, take it or leave it. We can sell it to China. We can sell it to Brazil, which are making those people upset. China's trying to develop their potash. Here's world fertilizer use. When I first started talking about fertilizer prices and driving around Texas, I was in Tennessee Colony, and I had my colorful slides on economics, and I mean, halfway through my talk, this guy got in the front row, just got red in the face, and he said some bad cuss words. I don't give a blank what's going on in China. I don't give a blank what's going on in Iowa. I don't give a blank what's going on in India. I live in Texas, and I know your blankets. And I was trying to tell him what a small, we're a small picture in this, but I got to looking at him. I mean, it was, he can't switch to corn or soybeans. It's hay and cattle. That's it. So with this high fertilizer prices, it really hurts under 36 inches of rainfall, which is a lot of production.